Good afternoon, everyone. My name is John Innes, and I have the honor of being the Dean of the Faculty of Forestry at the University of British Columbia. I'm delighted to be here this afternoon to welcome our featured presenter, Professor Tara Martin, for the webinar, A Prospectus for Conservation, and to thank UBC's President and Vice Chancellor, Professor Santa J. Ono, for being here today to moderate the discussion. I would like to begin by acknowledging that UBC's Vancouver Point Grey campus is situated on the traditional, ancestral, and unceded territory of the Musqueam people, and that UBC Okanagan is situated in the territory of the Silks Okanagan Nation and their peoples. I would also like to recognize that you are joining us today from many places, near and far, and acknowledge the traditional owners and caretakers of those lands. If you don't know on whose land you sit and would like to find out, I strongly recommend going to www.native-land.ca to find out. I should add that I'm currently speaking from the traditional territory of the Squamish Nation. As well on the screen, you will see the UBC Respectful Environment Statement. This provides the guiding principles to support us in building an environment in which respect, civility, diversity, opportunity, and inclusion are valued. We ask that everyone participating in this webinar help contribute to creating a respectful environment for your fellow alumni, guests, and speakers. On behalf of the Faculty of Forestry and Alumni UBC, I'd like to extend a warm welcome to everyone who is joining us today. Whether you are viewing from BC, across Canada, or elsewhere in the world, we are pleased to be able to present this online webinar during the extraordinary time we are all facing, and we're really very grateful to have you all with us today. A quick bit of housekeeping before I pass it over to our moderator. If anyone is experiencing any audio or video issues, please reach out to the chat feature in GoToWebinar for assistance. I'm really lucky to be joined here today by Santa J. Ono, President and Vice Chancellor of the University of British Columbia. He is also a professor of medicine and biology, with research encompassing the immune system, eye inflammation, and age-related macular degeneration, a leading cause of blindness. He also serves as Chief Advisor of the British Columbia Innovation Network. Santa, thank you for being here. I will pass it over to you, and I'm looking forward to Tara's presentation and the conversation that follows.
Thank you very much, John. I'm excited to be here today to introduce Professor Tara Martin to lead what is sure to be a lively discussion. Let's get started. The traditional approach to conservation science is to observe and model the impacts of threats, logging, mining, fishing, climate change, for example, on species and their habitats, to publish a paper of the findings in peer-reviewed journals and hope that policymakers will take action. Professor Tara Martin believes this approach is not enough, and that scientists must go further to offer practical solutions and blueprints for conservation action. With hundreds of species at risk and limited amounts of time and money, policymakers need expert guidance on how to use resources most effectively and to invest where the likelihood of success is greatest. Since 2018, Tara's research has been transforming the way conservation research happens in British Columbia and well beyond. Using a tool called Priority Threat Management, Tara and her team have combined robust empirical data with expert knowledge to offer prospectuses for conservation, not only here in British Columbia, but also in Saskatchewan, New Brunswick, Australia, Indonesia, and Antarctica. In today's webinar, Tara will use her recent work on the Fraser River estuary as an example of this innovative approach. with 102 species at risk in the estuary. Tara and her colleagues have studied the impacts of current and future developments and created a clear action plan with price tags for conserving every one of them. Before I introduce Tara, I want to let everyone know how this webinar will unfold. Tara will present to us her recent work on the Fraser River estuary, and once she has completed her presentation, I'll be moderating the discussion based upon your questions. To add your questions to the conversation, we are using our online audience engagement platform. It's called Slido. You will have received instructions in the reminder email for this webinar, and some of you have already inputted questions. But as a quick reminder, to enter your own question, please just go to Slido, slido.com. Use our event code UBC Forestry with no punctuation or spaces to sign in to this particular event. You will see these instructions on the screen, and the link will be shared in the chat just before the question and answer period. The session is being recorded, and a link to the video will be sent to all registrants in the next couple of days. I would now like to introduce Professor Tara Martin. Professor Tara Martin is a Liber Ero UBC Chair in Conservation and a Professor in Conservation Decision Science in the Department of Forest and Conservation Sciences. She leads the Martin supervises 12 graduate students and works with a wide range of collaborators and supporters. Tara is a member of the International Union for Conservation of Nature Climate Change Specialist Groups and co-leads the climate adaptation theme. She holds a PhD in ecology from the University of Queensland in Australia. Tara, thank you so much for joining us today. Tara, I now turn it over to you.
Thank you. I'm honored to share this time with you today. I'm joining you from Salt Spring Island, where I was born, on the unceded territory of the Penelakut, Cowichan, and Wasanich nations. As ecologists and conservation scientists, we're trained to make predictions and describe the impacts of various land uses and threats to biodiversity. But we spent far less time predicting solutions. And this is a real gap. This is a problem in our field. In order to make this leap from predicting impacts to solutions, colleagues and I have been developing a new field called conservation decision science, which draws on various disciplines from mathematics, statistics, computational science, and economics with ecology to inform what actions we should take, where we should take them, and when in time across various regions in order to conserve as much of our biodiversity as possible. So I'm going to share a story about how we use this new field to develop a prospectus for investment in conservation action here in Canada. Before I do, I just want to give a shout out to my amazing team of grad students. Everything that I say today is due to their brilliance. So this image is of a southern mountain caribou. This is a female from the Selkirk herd. This is one of 3 remaining females. In fact, there are only 3 remaining females of this herd. Essentially, this herd is now functionally extinct. These are old growth forest specialists that feed on ancient lichens, and these forests take centuries to replace. This image is provocative because the story of this southern mountain herd is shared by many other species. In the last 5 years alone, over 90,000 hectares of its critical habitat has been logged. And so why is this happening? We've been monitoring this species for decades. We've seen that it's been in decline, but we've failed to make decisions about what to do to conserve this species. This issue of conservation failing is not unique to Canada. And there's many complex reasons of why conservation is not achieving the goals that we would like it to. And one of those first reasons is that we often lack brave, effective governance and leadership. Another related reason is that here in BC, we don't even have environmental laws that are specifically designed to protect species and ecosystems. We have no species at risk legislation here in our province. The pressures on our biodiversity continue to outpace conservation efforts. Often our protected areas, which are one of our best defenses that we use to conserve biodiversity, they're too small. They're in the wrong places, or they may not be well managed. We have insufficient conservation outside of protected areas. We have global issues of overconsumption, inequity, poverty, which contribute to biodiversity decline. And we often lack sufficient resources to do the things that we want to do, to save as many species as we'd like to invest in the conservation actions that we'd like to. But I'd also argue that we're not using the resources, the time and the money most effectively. And I'm going to dig deeper into that during this talk. So let's begin with a toy example. So each of you is in charge of recovery of endangered species in Canada, and you have $1 million to spend. You can spend your $1 million recovering the southern resident killer whale, and you can see its trajectory right here. It's expected to disappear in 2030 if we don't do something. Or you can spend your $1 million recovering the burrowing owl. You only have $1 million to spend, and each species is going to cost you $1 million. Which species do you choose? Because I can't have any feedback with you, I'm going to guess that some of you are thinking, well, I'm going to choose the orca. Why? Because I just like orcas, or possibly because it's declining faster. Others might be thinking, well, I'm a birder. I love birds, and also the decline is a bit slower for the burrowing owl, so perhaps I have a better chance at recovering that species. It gets more complicated. You still have $1 million. Now you could spend your million recovering the orca, or you could spend your $1 million recovering the burrowing owl plus the leatherback turtle. So you could get 2 for 1. Now what do you do? Obviously, this is just a toy example. It's very simple, and we're missing a whole bunch of information in order to make an informed decision. For example, we would like to know, what is the likelihood that the actions I could take would lead to recovery of these species? Conservation problems have been described as wicked problems. And this quote from Robert May, who was a well-regarded ecologist in our field who passed away last year, he's famous for saying, ecology is not rocket science. It's much harder than that. When you think about rocket flights, they obey well-understood laws. They're predictable. They vary in 4 dimensions, 3 dimensions in space, and 1 dimension in time. And most rockets meet their target. And if they don't meet their target, we can figure out why. In contrast, conservation actions often don't meet their target. And it's often very difficult to understand why. And this is because conservation are embedded in social ecological systems. We have numerous interacting elements. We have many nonlinear interactions. There's no central control. All of these characteristics are characteristics of complex systems, and they're characteristics of wicked problems. Wicked problems lack clear solutions because each problem is linked to other problems, and the nature and the characterization of each cannot be isolated. So this is the context in which we're working. These are not simple problems to try and solve. When we look at current approaches to conservation in Canada, there's 3 big issues going on. The first is it's simply taking too long to make decisions. The second is that we're focusing on single species. And the third is that we're prioritizing the wrong thing. So let's unpack that. First, we're taking too long from paper to action. So the Committee on the Status of Endangered Wildlife in Canada, this is called CSIWIC, they assessed the southern mountain caribou as threatened in 2000. 14 years later, the federal government published the recovery strategy for southern mountain caribou. So this recovery strategy tells us about all of the threats to caribou, it tells us about the ecology of caribou, and it outlines what the critical habitat is for caribou. This is the habitat that this species needs to thrive and survive. It doesn't contain any actions, however, about what to do to recover caribou. Those actions are contained in another document which follows the recovery strategy called an action plan. Well, we're still waiting for an action plan. That's 21 years since the species were assessed as threatened. In 21 years, we're still waiting. 21 years when threats can continue across critical habitat for caribou. Single species focus is not efficient, so most of these recovery strategies and action plans are built for a single species, and they take decades to complete. However, the threats to species are often the same, whether it's logging or fishing or climate change or all of those things intertwine. Because the threats are often the same, it means the actions to recover species are often the same. And so single species efforts, they ignore the potential complementarity between actions. And that's not a good thing. That means that there's a lot of inefficiencies and we're potentially wasting resources focusing on a single species when we could be focusing on multiple species for the same cost. Finally, we're prioritizing the wrong thing. So at the moment, species are prioritized based on their status and their trends. So status, whether they're vulnerable, endangered, critically endangered, and the trends, how their populations are fluctuating over time. What's missing is the cost of action. We need to know how much does it cost to recover these species? What is the expected benefit? Like, how likely are we to be successful? So how much will we improve the probability of persistence of southern mountain caribou if we were to invest in these actions? Finally, what is the feasibility of those actions? What's the likelihood that those actions would be taken up? So that's the social political feasibility. And what is the technical feasibility? How well do we know how to implement those actions to achieve success? The outcome of not including these things is that species with a low likelihood of recovery at a very high management cost gain top priority. And this is a problem when we don't have sufficient resources to invest in all of our 600 plus species at risk across Canada. So this problem is not unique to Canada. It's a problem that countries around the world are facing. And in response, we developed this framework called Priority Threat Management. This is a decision framework to help us build a prospectus for conservation action for multiple species across regions. We published our first assessment describing this methodology back in 2012, and this was led by my postdoc, Josie Cowardine. And the process does several things. First, it prioritizes actions for species and ecosystem recovery by their cost effectiveness. In other words, how many species can we recover in a given region for the least cost to society? It informs us of the most cost-effective actions to do and where to undertake those actions. It calculates the cost of recovering all species within a region. It calculates how many species or populations of a species we can recover for a given budget. And it's fast and inexpensive. In the time that it's taken to develop a typical recovery strategy in Canada, we can develop many of these priority threat management assessments. So we kicked this off back in Australia when I led the conservation decision group within the National Science Agency, CSIRO. And in each of these colored places, we developed this blueprint for action, this prospectus for investment that describes all of the actions that we need to take that will have the highest likelihood of recovering species for the least cost. Since returning to Canada, we've now applied this process across the country from the St. John watershed in New Brunswick right across to British Columbia. So let's dive into one of the case studies that I'm really passionate about because it concerns the area where many of us live. Before I do that, I want to just talk about the process, the priority threat management process. It goes like this. The first thing we need to do is define the problem, and then we need to clarify our objective. So what is the problem that we're trying to solve? Where, how many species, which region, who are the decision makers? And what is the objective that we're trying to maximize or minimize? So for example, we want to maximize the number of species that we can save for the least cost. The next thing that we want to do is identify the threats to all of those species. So what are all of the threatening processes and what is the impact of those threatening processes on those species? We then move to understanding and developing and predicting what the management strategies we could take would be to mitigate and adapt to those threats. And those management strategies are made up of a whole bunch of actions. These are on-ground actions. They also could be development of policy and law, but these are the things that are going to lead to the recovery of species because they are dealing with these threats. Each of those actions has an economic cost. It has a benefit in terms of improving the probability of persistence of a species, so the likelihood of recovery of a species, and it has a feasibility, so that probability of the action being taken up and the probability that it would be successful. Those are the three parameters that we need to quantify the cost effectiveness of these strategies. Once we have that, we can inform strategic investments, implement the actions, and monitor whether they're effective or not. So we published this paper late last year. Conservation in heavily urbanized biodiverse regions requires urgent management action and attention to governance. And this was led by Laura Keogh, who was a postdoc in my group, and she's now a postdoc at Oxford, and a range of collaborators across the Fraser River estuary. So this is the region we're talking about. This is the region that many of you live in and many of you were born in. And you know, if you can see my cursor, this is the University of British Columbia, and I'm speaking to you from Fulford Harbor down here on Salt Spring Island today. This is an incredibly rich region. In fact, it's one of the richest regions in the entire province in terms of its biodiversity. The Fraser River is really the lifeline for the entire Salish Sea. Humans have lived in this region for millennia. It's no surprise that humans have landed in these areas of richness, in these often in estuaries, because they have high productivity and they have so many things that can sustain our livelihoods. We've generated our livelihoods from these estuaries for millennia. Our work has also shown that there's a lot of species that rely on this estuary for their survival. For example, we have southern resident killer whales, we have 5 species of salmon, we have western sandpipers, pink fawn lilies, western bumblebees, western toad, Pacific shrew, green and white sturgeon, a raft of species which rely on this region for their persistence. So let's start. How do we solve this problem? We've got 102 species that we want to recover, and we want to make sure that they're going to be thriving in the future, and we want to do this for the minimum cost to society because there's many other competing things that we can spend our resources on, like health and education. We're going to solve this problem over a 25-year time frame, so we need to set some bounds in which we're going to make our predictions. In terms of the governance, we have multiple governments, we have multiple stakeholders, we have multiple decision makers within this region. It's highly complex, it's biodiverse, and it's highly contested. In terms of our objectives, so these are the things that we want to maximize. We want to maximize the persistence of species. And when I use this word persistence, I don't mean that we want to have a few salmon hanging around in 25 years. I mean that we want to have viable, self-sustaining populations of salmon that meet their ecological function, but also support us economically. We want to minimize the cost of these management actions to recover these species, and we want to maximize the feasibility of those management actions. So our next step is to understand the threats to this region. So there are a raft of threats to the region. It's highly complex. We have a long history of urban and industrial development. We have channel navigation and dredging. We have fishing pressure. We have invasion by invasive species. We have intensification of agriculture, gravel mining. We have sea level rise and temperature rise. These are the things that are happening right now. We also have a bunch of things that are proposed to happen. We have a Trans Mountain pipeline. We have a proposed terminal to port expansion, a potential airport expansion, a proposed coal mine, proposed jet fuel storage. There are many things literally in the pipeline that are planned to happen within this region. So once we understand these threats and the impact of those threats on our species, we can then move to thinking about, well, what are all of the alternative strategies that we can take to recover these species? And so here are just a few of the strategies that we could undertake in the Fraser River estuary. We could deal with problematic species. So these include invasive species and feral species. They also include hyperabundant native species. We can undertake aquatic habitat restoration. We can undertake pollution control, aquatic disease control, transport regulation, fisheries management, and so on. These are overarching strategies, and underneath these strategies are a whole list of specific actions that make up each strategy. Once we have these strategies, we can then think about estimating what's the benefit of undertaking a particular strategy to the recovery of our 102 species. So this is what we call a cost effectiveness equation. This is very similar to cost benefit analysis. CE is just cost effectiveness. The B is our benefit. The F here is our feasibility, and the C is the economic cost. The key difference between a classic cost-benefit analysis is in cost-benefit analysis, the benefit is an economic benefit. Cost-effectiveness means that the benefit is not an economic benefit. The benefit that we're interested here is the improved persistence for all of our species given we undertake a particular strategy. So we want to know, if I was to undertake pollution control, what is the summed improved benefit and persistence of our 102 species under that strategy versus doing nothing? Okay, and then we want to estimate what's the feasibility of that strategy, what's the probability the strategy is taken up and implemented and implemented correctly so that it is successful. And then finally, what's the cost of that strategy? What is the cost of labor, the cost of infrastructure, the cost of project planning, all of the elements that we need to cost out that strategy. Once we have those, we can then prioritize our strategies based on their cost effectiveness. So how do we get those parameters? Well, we undertake a lot of empirical studies. This is Leah Chalafor, a PhD student in my lab, collecting water quality information from the Lower Fraser. This is another PhD student, Dave, collecting information on salmonids in the Lower Fraser. Here we have Megan collecting hair samples on another project up on the Central Coast. And so we can undertake these studies and start to gather this empirical information. But the problem is in order to gather all of that information, that would take decades. And we don't have decades. We need to inform decisions today. And so what we do is we gather all of the empirical information that is already available, and then we gather all of the experts that are experts in the management and in ecology of these species. So this is a group of experts in salmon ecology and management in the Lower Fraser that we convened just before the COVID lockdown. We lock these people in a room for a week and we extract information from them about the benefit of each of these strategies to all of our salmon populations that we're interested in. We ask them about the feasibility of the management actions, and then we ask them about the cost of those management actions. Once we have that information, we can use our cost effectiveness analysis, and we can use other types of multi-objective optimization to put together these prospectuses for investment. And so let's look at some of the results for the Fraser River estuary. So here we have a graph. We have our 102 species, which have been lumped into 13 species groups, from marine mammals through to land birds. And we've grouped them based on the expectation that each species within a group is going to respond similarly to a management intervention. In other words, they're going to get the same benefit, okay? The next thing we have here is this probability of persistence. So this is the probability or the likelihood that a species group is going to be self-sustaining and thriving in 25 years' time. In blue, what we have here is our business as usual. So this is the baseline, if you like. This is what will happen if we continue to carry on like we're carrying on right now. And what this set is showing us is that there's only 5 species groups that are likely to have a greater than 50% probability of persistence under business as usual. This is not a good outcome. If we carry on as we are now, we are going to lose thriving populations of the majority of these species groups. If we then look at what happens when we implement these optimal strategies. So these are the most cost-effective strategies within the Fraser River estuary. Can we improve these probabilities of persistence? What we find in the light blue is that now with the implementation of these strategies, all groups are at least above a 50% probability of persistence, and 8 of our groups are above a 60% probability of persistence. So that's good news. In fact, it's even surprising for some groups, given the extensive changes that have taken place within the estuary. But it begs the question, can we do better? And are we still missing something here? So as I mentioned earlier, the Fraser River estuary, it's a highly contested region. The governance for this region is highly fragmented. We have a mix of jurisdictions. We have federal agencies which deal with stuff in the marine environment and other federal agencies that deal with stuff on land, and they often do not coordinate between the two. And so we were curious that, if we had good environmental governance in place, a governance body which was dedicated to the implementation of these strategies, could that improve the probability of persistence of this species? In other words, if we had a good governance, could it improve that feasibility? So the probability that these strategies would be implemented correctly. In order to determine that, we convened another group of experts, experts in governance, experts that had been working in governance throughout the Fraser region, and we asked them to design what they thought was the ideal governance mechanism for this region. Once we had that, and I guess the key features of that governance framework was that it was a co-governance between First Nations, the federal, provincial governments with liaison with municipalities. Once we had that co-governance framework outlined, we then went back to our experts and we asked them to re-estimate the feasibility of those strategies in the presence of this co-governance framework. And what we found was that across the board, it improved the probability of persistence for all of our species groups because it increased the feasibility of our strategies between 10 and 15%. And we think that this is probably quite conservative. So with management, so with the implementation of those optimal strategies plus co-governance, we now have at least 10 species groups with a greater than 60% probability of persistence. So now we have this prospectus for action in the Fraser River estuary. This took us a year and a half to complete for 102 species. And what it tells us is that if we continue business as usual, 38% of our species are likely to be around and at least have a greater than 50% probability of persistence in 25 years' time. That's under our do nothing strategy. However, if we implement these actions that we've identified, all of our species have a greater than 50% probability of persistence, and many have a greater than 60% probability of persistence in 25 years' time. How much does this cost? Well, the present value is around 381 million over 25 years. That's an annual estimated value of around 15 million a year. Or that's around 1 beer or latte per person in the Lower Mainland. Not very much for what we might get. That also led us to think about, well, what else do we get? If we invest in species conservation, what other co-benefits are generated from this type of investment? And this is really the focus of my postdoc Victoria Hemming's work right now. And so these estimates are still rough, but let's look at this. If the Fraser River fishery generates around 300 million a year, whale watching, which is quite dependent on southern resident killer whales, generates around 26 million a year. There's probably over 50 full-time jobs that would be generated from implementing these strategies, which would generate another 4 million a year. So that's a total of 330 million versus an expenditure of around 15 million annually. Even if we're an order of magnitude incorrect, this is still a good investment. So I just want to end by saying, if we all, raise a toast to the Fraser River, it's not too late to save these species. Thank you.
Well, thank you very much, Tara. That was absolutely fantastic. And I have to tell you, you may not know this about me, but I have been a long fan of estuaries. I grew up in the Baltimore, Washington area, and there's quite an estuary there called the Chesapeake Bay. And when I was in high school, it's not about me, I just want to tell you how important what you're doing is. I was involved in something called the Clean Water Act with Ralph Nader, and was very worried about the impact of pollution from Baltimore, from the factories on tortoises, on crabs, which had quite an important economic impact on that region. So the work that you're doing here is terribly important. I fully understand, and I'm thrilled to see how strategic you have been, and your sort of meta approach is really what's needed. I can imagine, since it's a wicked problem, that this kind of co-governance model that you've espoused is easier said than done. And maybe we can talk a little bit about that, but we're thrilled that you're here, and the co-benefit analysis is crystal clear. And at some point, we can talk a little bit about the competing needs of support from different levels of government, and how institutions or how the public can, with these competing needs for financial support from governments, how they can be supportive of your model of co-governance. And because I know that I often have to be at that nexus of different governments and different municipalities having to work together, and it's easier said than done. Well, would you agree with that? Let me start off with that.
Yeah. Thank you for that feedback. Yeah, I think that governance is key, and it's something that it's been quite uncomfortable for me to start thinking about governance. I'm a conservation scientist, an ecologist. I'm most comfortable when I'm out in the field collecting data, but I've realized that that's not going to help save these species and ecosystems. What's going to help save these species and ecosystems are these meta-analyses, are using the data that we already have at hand and determining where are those critical uncertainties that would potentially change our management actions from doing one thing to another. That's where we need to focus the additional research. Governance is key. We have an entirely a huge vacuum in the governance space when it comes to managing species and ecosystems in our province. We have a species at risk legislation federally, but that only applies to 5% of our land base. That's not helpful for the other 95%. And so species are falling through the cracks, and that's not good for certainty. That's not good for industry. That's certainly not good for species. It's not good for all the other industries that rely on those species.
I mean, education is clearly a key point here. Often industry views those who are interested in conservation as an impediment to the bottom line or their productivity. Can you speak a little bit about how institutions can support you and your team that's doing critical work in getting the word out about how in the long term it's actually a better idea actually to really think about how to come together and how to implement the suggestions that you make for the betterment of society? How can we help you?
Yeah. Well, I think it's a really important point that, often conservation has been pitted against industry, and it doesn't have to be that way. In fact, there's a lot of jobs that are generated through the merger of those two things. Also, industry needs certainty, and we've been working in a huge space of uncertainty. And I think this type of analysis where we can generate the return on investment for conservation aligns with a business model. And so I think what we've experienced is that industry is very interested in these types of approaches. And there's also this whole paradigm shift that's occurring right now in many of our industries because the heyday of resource extraction is over. It just is. And so as these industries evolve into a new space, this is the perfect time to start collaborating and building these prospectuses across Canada so that we have clarity around which areas are set aside for conservation, which areas are multiple use that we can have, conservation plus industry, which areas are dedicated to industry.
Yeah, I'm going to dive into some of the questions from Slido. And the first one is, how do you incorporate First Nations goals to prioritize what they consider important in their traditional territories? And what if those priorities are at odds with your recommendation?
That's a great question. So we've been working with nations in the Lower Fraser, plus we have a project which was developed, co-developed with nations on the Central Coast that specifically focused on salmon. And so this was with the Heiltsuk, the Kitasoo-Heihei, the Nuxalk, and the Wekano nations. And here, together, we developed a priority threat management assessment for 79 distinct populations of salmon. And so their values and their knowledge was directly basically underscored the entire process, the entire model. And really, I think that's the power of this type of process, is that we can combine empirical data with this expert traditional knowledge.
Fantastic. The second question, there are many questions, is the goal of this framework always to conserve the greatest number of species? Are there ever cases when conserving one species may threaten others?
Yeah, that's a great question. So there are. I mean, this is where ecology is complex. We have endangered species like sea otters and northern abalone, where sea otters love to eat northern abalone. How do you recover these two things simultaneously? And so we have, we build these models, and we have ways to interrogate that, to try and figure out how do we do that. We can also, there's other situations where, what I showed you today, we're treating every species as equal. We're treating a southern resident killer whale equal to a Pacific shrew, and that might not reflect our values. In fact, we might value the shrew way more. But what we can do is actually weight species based on our values, so we can incorporate our values into this type of process.
Now, there are differences of opinion, right? People like different species. So in your own team, do you ever have arguments about the recommendations that are made?
Oh, that's a good question. I think what we're always, we're always curious what the data says, and what we're looking for is where there's a huge divergence in opinion. So where we start to get concerned is when we have some experts saying that the strategy is going to have an incredibly huge benefit, whereas others will say it has almost no benefit, and that starts to highlight where there's a huge amount of uncertainty, that critical uncertainty that we need to unpack.
I was going to be worried if there wasn't disagreement in your team, but I'm sure there is. Not actually better decisions, don't you agree? So yeah. The next question we have is, hi Tara, do you know if BC is thinking of developing any provincial SAR legislation?
Well, yes, it has been. So it was actually in the last, in the 2017 mandate letter for George Heyman, that was front and center, develop a made in BC species at risk legislation. Now, sadly, that fell off the docket. It fell off the docket really around southern mountain caribou and backlash around protection of habitat for southern mountain caribou. And unfortunately, in the most recent mandate letter, that was not included again. So there's no mention of developing species at risk legislation in George Heyman's recent mandate letter. A group of colleagues, over 20 scientists from across all universities and other leading organizations in the province, we got together and we've written to George Heyman, we've written several papers on the need of why this is important, of why we need to have a piece of legislation which is specifically about the conservation and recovery of species, because at the moment we don't have that.
That might be one way we can help as a university, is that we do quite a bit of advocacy. So offline, let's talk. I met with Minister Heyman just last week. So let's see how we can be of support to you as an institution.
Wonderful.
You mentioned economics as useful to conservation decision science. Do you see a role for other social sciences, for example, political ecology or behavioral science in those decision science matrix?
Oh, absolutely, absolutely. And we draw on a whole raft of fields in the social sciences. As I said, we're trying to solve problems in this incredibly complex social ecological system. And so we need to bring together these interdisciplinary teams to solve these types of problems. And we have that in my group, where we have a real I guess, diverse array of skill set within the team.
All right, so we're nearing the end of the time. And so this is the last final question from Slido. You mentioned that single species approaches are ineffective. What are your thoughts on umbrella species, or protecting one helps others in similar habitats?
Yeah, this is a great question, and this is something, you know, that we've been talking about for decades. And so there is merit in that, in thinking about, well, what is the, you know, if I save this particular species, what is the complementarity to other species? And that is, you know, this is part of what we're trying to encapsulate in this process. Rather than using, say, an umbrella species, we're just being more explicit. We're saying, actually, there's, you know, there's not just salmon and orcas in the Fraser River estuary. There's all this other stuff too. And so why don't we just be explicit and estimate and look at all of the actions and what the complementarity between those actions are. So I think it's a useful concept, but I also think we can do better.
Absolutely, absolutely. And I do want to follow up and talk to you about how we can be supportive of not only your interactions with government entities and municipalities, but how we can be helpful for you in UBC. You know, we're incredibly proud of what's happening in Faculty of Forestry, but we also know that at UBC, we have an almost unparalleled group of individuals with expertise that's relevant to the success in solving these wicked problems. We have world-class biodiversity colleagues along with you. And let's talk about how we can continue to support you on this very, very important priority for the university. So before I close the webinar, I'd like to remind participants that this session has been recorded, and a link of the video will be sent to all registrants in the next couple of days. Now, before we conclude this exciting webinar, I'd like to give Tara a chance to provide a brief final thought for our viewers.
I think we're at a really exciting time in Canada where we have an opportunity to transform our thinking in conservation and make some enormous progress quickly. And so I think that, you know, if we can apply this type of process where we're really building these costed plans for species recovery, we can go a long way for recovering species and make sure that future generations get to enjoy the richness in our biodiversity that we've enjoyed. So, thank you.
Thank you, Professor Martin, and thanks for an amazing presentation. I'm sure that many people will share it beyond today. It's been a true pleasure to have this opportunity to speak with you. And I'd like to now turn it back over to Dean John Innes for his closing remarks.
Thank you, Santa, for moderating and sorting through the outstanding questions that we've had. I've been following them on Slido. We've certainly had a lot of questions. Thank you, Tara, for your presentation today and for your work. It really is truly valuable. I think you raised many, many questions, and one of the ones that I find particularly fascinating is how do we assess the differential value of individual species? We know that they have different meanings for us, but sometimes we tend to focus on the iconic species and forget about those that are less iconic, but equally important. Tara and Santa, you're welcome to turn off your cameras now while I provide just a few closing remarks. I'd like to thank all our viewers, UBC alumni and friends, for joining us for this memorable presentation by Tara Martin. The video from this webinar will be available in the coming days and sent by email to all participants. We wish everyone well in this time of uncertainty. Please be safe and stay healthy. And I wish you all a great rest of your day. Thank you for attending.